Good morning, everyone. I'm Jeff Davis from eWater, and welcome to our webcast, Customising eWater Source. Today we're going to talk about ways you can customise Source. With us, we also have Andrew Herron from Jacobs, formerly SKM, and we have Robert Brigart from CSIRO, who will talk about some of the customisations they've previously done with Source. So the main areas I'll be covering, I'll briefly cover the function manager and custom functions. The function manager in itself is its own topic. Mostly today I'll be talking about plugins, and I'll also talk briefly about external scripting and the service interface with a number of examples. So what are functions? Functions are user input, Excel-like equations used to set behavior for model inputs. They can be used in a large number of places throughout the model and replace time series inputs, and we'll go through some of the detail. So there's a number of different variables you can use in functions, basic time series variables, or you can use pattern variables such as a monthly pattern or weekly patterns. You can use piecewise linear variables with lookup tables to interpolate between X and Y values. One of the key benefits of using functions is the ability to use modeled variables, so to point to different things in the model. So, for instance, ordering could be determined based on how much water is in a storage upstream. So you can have your functions describe the ordering, but based on the current state of the model at that time. Then there's bilinear variables, allow you to look up and interpolate in 2 dimensions. And we also have context variables, which are fairly new, and they allow you to apply the same function in a number of locations that use modeled variables. So this is handy if you, for instance, you want to write your own constituent generation model using a function and have it based on the rainfall in that functional unit. You can write the function once using a context variable for rainfall and apply it across your entire model instead of having to create a new modeled variable for every functional unit and a new function for every functional unit. Date ranges are very important when you're looking up modeled variables and other variables in the model. So you can have it based on either a previous number of time steps or a date range or an annual repeating range. So custom functions, this is the first area for plugins. The simplest plugins are custom functions, and they're designed to perform custom processing on input data in the function manager. So when you first install Source, it comes with 2 custom functions, get restriction level and get restriction value, and these actually look up restriction curves. However, you can also write your own custom functions to do complex processing in C#. Cool. So I'll just go through the main area that we're talking about today, plugins. We'll go through some basics, some code examples, some caveats, and where we are going with plugins going forward. So plugins. Plugins are compiled .NET libraries that extend Source to perform custom behavior. It allows third parties to create modules that can be used for custom tasks. Examples of plugins that people have used: you can do your own nodes in the schematic or the geographic. You can build custom user interfaces that can automate some manual processes if you have some processes that the user interface at the moment isn't customized for, or bringing in custom data sets, such as parameterizing your model based on data that you have for your model. Then the basic constituent generation models and constituent filtering models. You can do custom parameterizers where you automate the process of land use change. You can do result transformations, so you could build your own reporting templates in plugins. For instance, MDBA have their operators have a custom report, a PDF that they have to generate every day, and they could do that through a plugin. And also data importing and exporting. You can build your own plugins to import custom data types or hook into corporate databases to import data from those databases or export data in a reporting way to those databases. So plugins are loaded into the source assembly memory space in .NET, and Source uses what's called in C# reflection to find plugins that are decorated with appropriate attributes, or they implement an aspect of the API, which is the application programming interface. And once they've been loaded, they operate just like other parts of Source. So from an architectural point of view, and all of our node models in Source, except for the storage node model, are architecturally set up just like plugins. So plugins aren't second class at all. They are first class citizens in the world of Source. Cool. So this is the basic plugin manager for add-in plugins. We've recently added the ability to pull them down from online. So this is where you can pull them from the Toolkit website, which has all of our community plugins available. But you can also install them from somewhere on your computer if you've been given them from someone else, or if you build your own plugins. So this is the basic application programming interface, the API, for building your own node model. So node models are one of the more complicated plugins to build. There's a number of components. So that some of them are fairly simple components, such as you need to have a node model, obviously. You need an icon wrapper to show the icon in different contexts. You've got the feature editor control, so this is the user interface component of your node model, and you need an palette shape. So this is so you can represent the node has different states, such as the water user, where it has one icon on the palette, but it can change based on what the settings you've done in that node. So we have attributes such as works with, and we have like AKA. So I'll show you what that means in terms of code in a minute. So, and you can make your node model simple to begin with, and then you can add in features if you need to, such as ordering or ownership. There is also, you need to do an XML file for the persistence, which is the loading and saving of your node model into and out of the database. So there are some caveats. When the database changes, you may need to write some SQL in order to upgrade your database when we make core changes to the model. And plugins must be provided separately to the project. So plugins aren't stored in the rsproj file, and they need to be upgraded. You need to have a new version when we upgrade new versions of Source. So if you've got a project that depends on a particular rainfall runoff model plugin, and then in 3.7 and you want to upgrade to 3.8, you need a new version of that same rainfall runoff plugin to be able to load your model in 3.8. Cool. I thought I'd talk briefly about the external scripting and service interface. It allows you to run Source from the command line or from an OpenMI compliant system over the network. So it allows you to run simulations in parallel, and we have example scripts on the Source community website to show you how to do it. And it also runs over the service interface. So if you want to run the same model 100 times with different inputs, you can distribute that over a cluster of computers. And so it will all run in parallel. And you can also run in parallel on a local computer if you've got one for each CPU that your computer has. This is just an example batch script. Where you're running the command line in a server mode, and then these are all the runs. Cool. Okay. So let's have a quick look at some examples. So you get to plugins via the plugin manager. We can look at the plugins that are available online. You can see we've got a lot of example plugins. We have plugins from different organizations, such as from DERM, and this one is from SKM and the WA government. And here's another one from Jacobs. Sorry, they've updated the name to Jacobs. We just haven't updated their icons yet. And this is the list of plugins that I've currently got installed. So I've installed ePilot sharing, which is a custom function, LASCAM, which is a rainfall runoff model. I've got single catchment scenario, and a number of others. I'll just quickly show you a couple of the plugins. So in here now, instead of just having a schematic or a geographic, I have a number of different ways I can build a scenario. So I might build a network from a CSV file. This is an example plugin, mainly to demonstrate and give you the code that you'd need to do a similar process for yourself. We have in the Source community, we have documentation on how to, step by step, on how to build plugins for custom functions and rainfall runoff models, but then we tend to do by example. So we show you examples of plugins, and as you can see, these are all our examples. Example constituent filtering, generation, custom functions, and this is the example scenario creator, where you can just see the basic setup. I've got lat, long, surface area, volume, catchment, and an XY and the type of node. Cool. And then I've generated a network based on the CSV file. Cool. Cool. I might now, are there any questions for me before we move on to see some real-world examples from Andrew and Robert? Okay, I might hand over to Andrew, and he can tell you about some of the plugins that he's built for his work.
Thanks, Jeff. I just want to briefly talk through the background of Source at the moment in terms of developing things. And so I just wanted to chat through how you might go about starting to develop this stuff, and then a few examples as to what we've done. So first of all, I'd like to talk about how you actually go about starting to code a plugin. So the first thing you want to do is keep an eye on the overall outcome in terms of where you actually want to get this plugin to be at the end of the process, but break it down into much smaller pieces. So the first thing would be to design what the user wants to see, or a very first version of that. And from there, you sort of test that within Source to make sure that when yourself or other people using the code will actually be able to use what you've designed. And then keep on testing it until you're happy with how it works. So in terms of the detail of the code itself, there's a couple of ways you can do it. You can code the entire thing, but test it in small pieces. This is probably not the best way of doing it because you may end up losing the overall concept or not exactly sure where your code's falling over. Probably the better way to do it is to code it in small chunks and test to make sure those pieces are actually working before moving on. A bit of help around this stuff is also to look at the Object Explorer within Visual Studio. So this allows you to look at all the references which Source has access to see the most appropriate thing for yourself to actually use that functionality to solve a problem you have at that stage. And the other thing is to seek help from others. So there's lots of general .NET and C# tips and tricks online, and specific time and source-based functions can be found by talking to other developers or with eWater themselves. And probably one of the most important things about this stuff is how you store and maintain and exchange plugins so yourself and others can actually use them. Having some form of backup of what you've done is really, really important, because often you will make a change to a piece of code and not know why it's all of a sudden broken. So it's always nice to be able to go back to a version which you had which you knew was working. And in terms of working versions, having something to be able to track all your changes which you've made, to find out what you've done yourself or what others have done on the same piece of code, is very handy and allows you to review things quite quickly. And probably one of the most important things when beginning to code is giving your variables some obvious names to understand. So it might be flow at storage, for example, makes a variable name which is easy to understand, versus like var1, which someone reading through your code may not understand what that is. And this is especially important if you're not around to be able to explain what you've done. So just a bit of an overview as to what we've done in our time playing around with eWater Source from several versions ago all the way to now and continuing forwards. So we've developed a whole lot of different plugin types, from rainfall runoff models through the modifying scenarios, setting up scenarios from the start, and also obtaining results as well. So these are coming very handy to be able to streamline what we're doing and minimize the user input errors when you're moving big data sets in and out from one model to another, or from one revision to another. So one thing which Jeff wasn't didn't have shown on his is that you can also create catchment models as well, which we've done one of those to play with groundwater as well. So basically, if you can think of it in Source, you can probably write a plugin to actually do it. And the other thing which we've also done is work with stuff outside of Source to be able to set up input data and also optimize results and loop around various different runs. So we've taken the example background which Jeff was talking about and used the script to run specific custom solutions which we've been after. And also we've also done programs to be able to set up data, so gridded data for input to both rainfall and evaporation. And unless there's any questions, that's all I had.
Andrew, there was one question from David. Any groundwater specific plugins?
Yes, the catchment model, which I briefly spoke about, is a what we're calling a networked groundwater model. It enables water to be moved around within a source model based on the groundwater flow paths and doesn't have to follow the stream network, and allows both water quality and quantity to be modelled in this layer, and allows you to have multiple aquifers above each other as well. So that's one of our more recent ones which we've put together and are currently working on developing further.
Cool. Thanks, Andrew. I might hand over now to Robert Brigart from CSIRO. Who's going to tell us some of the things that they've been doing with Customising Source.
Okay, good morning everyone. I'm going to talk about two things today. We'll start off with a simple case of where we've developed a plugin for use in Source. Basically, we had a source catchment model and we needed to calibrate it. We intended to use the flow calibration wizard built into Source. And an investigation into the data and the catchment found that due to the low and ephemeral flows found in this catchment, that we'd actually be better off and we'd obtain a better result for the calibration if we used a different objective function to the suite which is provided by default in Source. So in order to achieve this, we were able to use the plugin functionality to write our own objective function plugin and use it. On the screen, as you can see here, this is the flow calibration wizard. These are a list of the objective functions available by default, and down the bottom you can see that this is a new plugin that we developed, which has now been made available and which is able to be used just as easily as all the built-in ones. And just to show you how easy that was to achieve, this is a Visual Studio solution where we've referenced a couple of the core DLLs that come with Source for the particular version we were targeting. I implemented a class which implements the iSingle Objective Evaluator interface. Jeff touched on the fact before that in order to create plugins, typically you inherit from different interfaces or mark up your classes with attributes. In this case, it was inheritance. Basically, then that gives us most of these methods as placeholders in order to populate with our own information, so giving the objective function a name and actually implementing some code which will, given the two time series to compare, will give us our actual objective. This is the actual class which is used by the previous class I showed to take the calculated time series by the model and the time series we're comparing against, and which will return the objective score. And creating the plugin was essentially as simple as implementing this. Well, I won't get bogged down in the specifics except to say that a lot of these handy functions that I've called here were actually part of Source, their code. So some of the mathematics that I used, it was all either built into Source itself, or it was built into C#. So that was a nice, easy thing to do. Basically just compile this and then through the plugin manager, load it in, and then it would appear here as a new option, ready to use. My second example that I'd like to speak about is a slightly more elaborate case, for which I prepared some slides. This was basically a job to perform a sensitivity analysis on a source model, and we decided to use the Amazon Web Services compute cloud to achieve this. And I'll just give you a bit of an overview about what we did and how easy it was able to be achieved, and the fact that we used the source service interface to achieve it. So essentially we needed to perform a sensitivity analysis on a source catchment model. We used an approach which meant that we generated a series of parameter sets that we were going to run through the model a certain number of times. In this instance, we were going to require 20,000 runs of our catchment model. Each individual source run took 2.5 minutes on a pretty powerful local machine. So if you do the math on that, it would have taken over a month of computing time on that machine to complete. And that's why we decided to have a look at using the AWS cloud. A high-level overview of the steps involved in the sensitivity analysis. Step 1 was to define the parameter space. That's basically coming up with those 20,000 parameter sets. Step 2 was to run those through Source, which is the main point of the talk, and gathering together and analysing the results of those runs is a post-processing step, which I'll also not be covering. Amazon Web Services, from a high level, provide many different types of services. The main one that was utilised was what's called the Elastic Compute Cloud. This is essentially all of the virtual machines which is doing the heavy lifting and actually doing the processing of the model. They also provide database services, a queue service, and some storage services, which were also utilised in the solution. Each virtual machine that we spin up, the machines that are actually going to do the work, Essentially, they were running Windows Server 2012, and we installed Source on them. We also installed a client application. This client application was set to run on boot up of each of these virtual machines. And what the client application does is it looked at the database, took a job off the queue, and was able to get the parameter set for that job, and then it ran Source using the Source service interface with that set of parameters, and then was able to store those results of that run to a cloud store. And basically it repeats that. Each of the virtual machines repeats that process. There were 20 virtual machines that we had running. Each one of the machines was a dual core machine, so we spun up 2 Source service interfaces per machine to utilize both cores. We use the service interface because it keeps the Source project loaded in memory. So even though a new parameter set would be run, and then the results saved, and then we'd repeat that process, because the service interface keeps Source running alive, it actually means that we don't waste valuable CPU time by having to do a cold load of the project again every time we wanted to run a new parameter set through. So that was really handy. This is a pictorial representation of what was actually happening when we ran this. So launching from our desktop computer, we populated a database with all of the 20,000 parameter sets that had been derived in a pre-processing step. We populated the queue with a unique key which matched to those parameter sets into a queue service, and we started up all the VMs, which themselves started up Source, which loaded the Source models and got them in a ready state to accept parameter sets for running. And then the compute cloud would take a job off the queue. It would then get a parameter set from the database, execute that parameter set through the Source model, and save the results of the run to a cloud service, storage service. All the meantime, the main PC, which is monitoring this process, would be polling the queue to make sure that when we get to 0, it's time to shut everything down, and then it would tell all the VMs to turn off and retrieve the data from the storage service. Just quickly, in order to write some code which interfaces with the Source service interface, it's actually quite easy in Visual Studio. What we're able to do is, when you basically start up the Source service through the command line, and then in Visual Studio you're able to add a service reference. And what this basically does is it allows you to get your hands on an object in which you can then call the methods on in Visual Studio, and these are the methods that are available through the service interface. So you can do things like load project, play data in, set recorders on and off, set the time span for the run, invoke the run, and get it to save recorded time series to a file. And then our client application and our virtual machines was then able to take that data and send it to the cloud store. Likewise, it was also able to input the parameter sets that it had derived from the cloud database and set those into the model through these methods in the service interface. That's all I've got to present today. So I think I'll open this up to some questions.
So participants can either raise questions through the chat window, or you can unmute yourself and speak through the microphone. We might take questions in general for Andrew, Robert, or I now. Okay, so just before we go, I thought I'd show you where the community plugins are on the Source community site. And here you can get more information about the community plugins and documentation. And one of the benefits of making your plugins a community plugin is when we do make core changes that break your plugin, for such as we change the API, we will update your plugins when they are in the community plugin suite. And now with our new online plugin management, it's much easier to distribute project files without worrying about the plugins, because they can automatically be downloaded and installed online with all the new versions. We have a question, Brigart, Robert, about the cost of the AWS services.
Yes, okay, so that is an important consideration. Basically the cost in terms, I'm assuming the question refers to the financial cost rather than the time cost in getting it set up. And the answer to that, I believe, to get the 20,000 runs complete, which we're able to actually, I forgot to mention that the runtime we managed to get down to, I think, less than 4 days, down from that over a month. It was about, I think it was $800 or $900 worth of computing time. That was 20 virtual machines, each dual core, so essentially 40 source service instances running simultaneously. And also a slight additional cost, very slight, which was to actually store some of those results, because we use the cloud store services, and they charge you a small fee to upload and download above certain amounts, but that was negligible compared to actually crunching the numbers. You've mentioned that it was good value.
Cool.
Yeah, I thought so.
Cool. Okay. Thanks, Robert. So we're actually going to be running a Customising eWater Source course on the 12th to 14th of May in Canberra. And for more information and to register, you can go to sourcetraining.ewater.com.au. Thanks a lot for joining us for Customising eWater Source. And if there's no more questions, thank you very much.